Hey, can you hear me and see me? Something weird happened. I could swear that I clicked on live stream. Yeah, on starting live stream, but looks like the stream did not start. So, can you guys hear me right now? Yeah, I swear I clicked on it. I was talking for the last 4 minutes. I'm not late. I was exactly on time. I started the session and I started talking, and weirdly, I was like, where did everybody go? Anyway, you can you hear me and see me right now? Yeah. Hey, Rajan, yeah, good to see you. It's all good, right? You can see me and hear me. Just give me a thumbs up before I start this time around. Yeah, I think this computer is behaving a little funny on me right now. I can swear that I started on this. Hey, Raga Reddy, what's up, what's up? All right, sure, we are live right now. So, आज हम लोग किसी चीज बात करने वाले हैं? Ionic and atomic radius. Yeah, yeah. So I was not live all this time. That's funny. That's really funny. I clicked on this. Anyway, yeah, atomic and ionic radii. Quickly, as always, what we're going to do is हम लोग देखते हैं कि क्या पढ़ चुके हैं ऑलरेडी और क्या पढ़ने वाले हैं. What have we already studied? Yeah, and periodic table. In part one, we've done all of these things. We've looked at naming the elements of greater than 100, z greater than 100. We've looked at classifying stuff into SPDF. We've looked at electronic configurations. आज हम लोग करने वाले हैं specifically ionic and atomic radii के idea, maybe a little bit more. Periodic trends की बात करेंगे, specifically ionic and atomic radii. But why are we going to talk about hi Rise and Shine? Why would we talk about atomic radii? Entire session on atomic and ionic radii? क्यों? This is an interesting thing, right? Till now you studied hydrogen. हाइड्रोजन में होता है एक इलेक्ट्रॉन और एक इलेक्ट्रॉन का ठीक है इतना फर्क नहीं पड़ता है. If you have more than one electron, things get interesting. क्यों? क्योंकि atomic orbitals they behave, yeah, they have a weird way of behaving with each other. You remember atomic structure में मैंने आपको पढ़ाया था कि you don't really know exactly where the electron is going to be, but you have some idea, some shape, yeah, some sort of a prediction of probability of कहाँ पे होगा. And these electrons, they also interact with each other. Okay, keep this in mind. जिसकी वजह से there's something called the shielding effect that comes in picture. इसलिए atomic radii is really, really weird. We'll talk about this in some detail today. Atomic radii, that's the focus of today, okay? As well as ionic radii. So we look at all of this, we look at these graphs and what do they mean, and maybe we'll do a little bit of ionization enthalpy. That's the plan for today. Okay, let's get started. And in the following sessions, we'll do the other properties and also we'll do electronegativity and all of that. No, Piyush, I don't think you'll face any difficulty. You'll be all right. You'll be all right. Trend started. Yeah, absolutely, Einstein. You can be here. Hi, Utkarsh, for sure. Yeah, you can be here for sure. You can look at the first session later on. You can look at that later. So yeah, you know the drill, right? What I do is in starting of my session, I do questions from the last session. So maybe थोड़ा बहुत आप इससे कर सकते हो. Naga Saab, I think it's only for you that the voice is low. I don't think there's anybody else who has that issue. I know you pointed out last time as well. But I'm on full blast. And I also checked my volume over here. We can do that right now. We can just lay it up. Control Shift T. Hold on. Yeah, it's good, bro. Volume's good. Maybe check it at your end. I've just checked right now. So, which of the following sequence represents atomic numbers of only representative elements? Do you know this? It's okay if you miss my first session. You can read this up in the NCRT. There's no big deal. है ना? Rise and shine is fine. Rise and shine. इसका आंसर बताइए. Representative elements कौन से हैं? What is representative elements? किसी को याद है क्या? Do you remember? We're gonna do this. Control F. Representative. Did I type that right? I hope I typed that right. Representative. What is this? Ah, here you go. S और P block को representative बोलते हैं. This is what we're going to do, guys. You have to read the NCRT. There is no way out, and this is me proving it to you. तो S और P block को हम लोग बोलते हैं representative element. Okay. What is this? 55 is 54 plus 1. What are your noble gases? याद है क्या? 2, 10, 18, 36, 54, and then something weird happens. Oh God, how much is 54 plus 14 plus 18? That's 32, 86, and then it's 118, I think. Right? ठीक है. These are your noble gases. Okay. तो इससे हम लोग फिगर आउट करेंगे कौन सा कहाँ पे है. This is S block. This is also S block. 48 is weird. 48 is neither. 48 क्या है? 48 is D block. So this is out. ठीक है. This is S block. This is both of these are P block because this is 54 and 54 minus 3 and 54 minus 5 still works because P block में होते हैं 6 electron. I can reduce up to 6 and I'm still good. What about 37? Yeah, 36 plus 1. What is 49? 49 is scary. 49 क्या होगा? 49 is 54 minus 5. Absolutely, 54 minus 5. Okay, this works. Looks like B works. B are all P block elements. These are all P, and this is S. Do you want to look at the actual elements? We'll do that very quickly. 3 to क्या है? 3 to lithium है, hydrogen, helium, lithium. 33 is 36 minus 3. This is 54 minus 1, and this is 86 plus 1. So ये है S block, ये है S block, और ये दोनों है P block. Okay. So B and C are both correct. What about this last one? 22 is 18 plus 4. Oh, not good. 18 plus 2 is S block. उसके बाद है D block. So this is D block, hence this is wrong. What are the answers? It's B and C. It's B and C, right? Utkarsh, if you have any issues with that, please try reaching out to the support. Yeah, it's not something that I know something about directly, but I hear you. Reach out to the support team. Is there an email that you can reach out to? I can maybe ask around. Yeah, I'll take a screenshot of this comment and I'll send it to people who may be able to help. Hold on. If you can maybe share registered number and stuff, you know where to reach out to me, right? I can share it with the team. So when I share this with them, they're going to ask me for registered account number, that registered phone that you did with this. You can ping me with that if you feel like it. I teach camp, is where you can reach me on Telegram or on Discord. C is right, B as well, right? Dono sahi hai. B and C are both right. You want to see what these elements are? Let's do that. Control T. We're going to go to ptable.com. Let's do that. People who did not attend last session, it's all right, don't worry about it, बाद में देख लेना, but देखना जरूरी है. I think if you don't watch this, it's all right, but read up the NCERT. देखो ना देखो video तो secondary चीज है, but NCERT पढ़ना, that's not something I feel you should skip at all. All right, so let's look at the elements. What did we have? We'll have to do a little bit of alt tabbing, right? क्या था इसमें? बहुत छोटा है, मुझे नहीं दिख रहा है यहाँ पे. क्या है इसमें? 37, 49, 51, 54. 37 किसी को याद रखेगा? इधर डाल देते हैं. I'll put it in the chat here. 37, 49, 51, 54. That's the first set. Okay, the second set is 3, 33, 53, and 87. ठीक है. These are the two sets of things, right? I put it there ताकि मुझे देखने में आसानी हो यार. It's difficult to keep alt tabbing here. What is 3? 3 is clearly lithium. 33 क्या है? 33 means 36 minus 3. So krypton minus 3 is arsenic. That's right over here, arsenic, right? Germanium यहाँ पे arsenic. Okay. What is 53? 54 minus 1. Iodine is 53. Wow. Let's do it this side. ये रहा iodine यहाँ पे. This is right over here. This is right above my thumb. That's iodine. 87 is 86 plus 1. Radon plus 1. Ooh, francium. That's a scary one. That's very, very reactive. What about 37? 37 is 36 plus 1. Krypton यहाँ पे है. इधर krypton है. ठीक है? Right in the end is krypton. 36 plus is rubidium. Right on the other edge. X block element. 49, 49, 49 should be here. Indium and thallium में क्या special है? We'll learn about when we do P block, okay? When we do P block, indium and thallium are special. Okay, indium is there. 49 के बाद क्या है? 51, 54. They're all going to be here. 51 is antimony, yellow. SB, antimony, Sebastian. Now, what does SB stand for? Hold on. What does SB stand for? किसी को मालूम है क्या? What is SB stand for? कोई बताएगा? Sebastian, that feels wrong. 51 is this and 54 is xenon. Yeah? All right. Steve Rogers, English. Hey, use AI, man. मैं जो बोल रहा हूँ, whatever I'm saying, you have ChatGPT. You have so many awesome things. Go to AirChat. Literally just play my video on AirChat. It'll give you real-time translation into English. It's a beautiful app. You can do that. Yeah? Language barrier is a thing of the past, my friend. All right. So xenon is 54. We're good, right? We're good. You have to absolutely keep this periodic table open to get stuff done. Let's do the next question. An element X is in its ground state. The value of principal and azimuthal quantum number for last electron of element X is n equal to 3 and L equal to 1. Spin multiplicity for the given element is 4. What is happening over here, right? Then according to given information, correct information is what? Spin multiplicity for the given element is 4. What does this mean, guys? I have a feeling कि ये JEE Advanced का सवाल यहाँ पे गलती से आ गया है. So we will nicely skip this question. I think we'll skip this question. Let's not do this one. Let's do this one. This is significantly easier. Yeah, we can come and do that. If you feel like doing that question, let me know in the comments. Yeah, there was one JEE Advanced question that slipped into this, and I feel that we won't do that right now. Let's do this. This is also JEE Advanced का BYQ है. If a value of spin quantum number S is equal to minus half, 0 and half, usually क्या होता है? It is plus or minus half. Now I'm saying it's minus half, 0 and plus half. तीनों हो सकते हैं. Calculate the number of groups in the new form of the periodic table if all the other rules of electronic configuration remain the same. This is a cool question. It's okay, rise and shine. Don't worry about it. This is something that is just after atomic structure. Rise and shine. You can do this from atomic structure. You don't need to know anything else. Okay, it may be a little difficult because it's new, right? Anything new is difficult. So you gotta see what you gotta do. You have to read a book. That's the first step. Attending session is fine. It's great. Good you're making effort. Must read books. Books पढ़ना बहुत जरूरी है. If the value of spin quantum number takes 3 values instead of 2, क्यों है 2? देखो, usually it's plus or minus half in one orbital s. Then you've got 3 of p. You've got 5 of d. And how many do you have f? F has 14. But we don't care about we don't care about f so much right now, because the f orbitals they don't contribute to groups, right? Groups are s plus p plus d. मतलब क्या हुआ? Go back to the periodic table. These are basics, guys. S के 2 हो गए, first two are S, yeah, right on the corner. D के 10 हो गए बीच में, ठीक है, and P के 6 हो गए. So that's 6 plus 10 plus 2, 18 groups, right? Look right at the top, the groups. Group number 18 right over here. If you go all the way to the other end, you got group number 1. Okay, group 1 to 18, right? So the groups have to do with total number of electrons in S, P, and D. And that makes sense. What are the number of orbitals? Right? So you have 3 spins instead of 2. 3 different subshells. What is the total number of orbitals? You got 1 plus 3 plus 5. Hey, why are you guys solving this question? इतने लोग तो हाय हेलो बोल रहे थे. नागा, उत्कर्ष, गुफ्ती जी, राजन्या, what a call out name, I'm going to be the teacher. Mehak, आंसर बताओ इसका. How do we do this? Yeah, so ping me. No, Utkarsh, what am I going to do here, bro? I'm teaching you like atomic structure here. There's nothing I can do for you here. I'm not going to call somebody and say, hey, iska substitution. How do I do that, dude? The best I can do is pass it on along the chain, right? So ping me. I've given you a solution. Usko karna chao karo. Otherwise, up to you, man. Do whatever you like. Arnav, JD Lee is what I follow. Yeah. Can we look at this one? See, you've got 3 spins instead of 2. So S, P, D, and F. And F doesn't matter when you're counting number of groups. Okay, only S, P, and D matter. Okay. So S, P, and D, when you add them up together, you get a total of 5 plus 3 plus 8 plus 1, 9 orbitals. Okay. So if you get 9 orbitals, how many electrons can you put in? If you have 2 spins, then you get 2 into 9, which is 18 orbitals. Right? Sorry, 18 electrons, and hence 18 groups. So now if you have 3 spins instead of 2, 9 says Rajanya, good. 3 into 9 ho jayega na. It'll be sorry. Instead of 3 into 9, it will become 3 into 9. Why? Because now each orbital can have some weird thing. I don't know how it's going to work, right? Like, let me just make this that says 0. This one is plus half, where this denotes plus half, this denotes 0, and this denotes minus half. Right? So each orbital now has 3 electrons. Okay? So 9 into 3, 27. So the answer is 27 groups. That's it. What do you think? What do you think about this question? So 27 groups should work. Pretty cool, right? Yeah, Steve, exactly. 27 electrons, hence 27 groups. Good one. Yes, Naga. Rajana, 18 was with 2 electrons, but now you have 3 electrons in each subshell. Yeah? So question is wrong. Steve, why? What are you saying, bro? It's saying you theoretically have another thing where you have these 3 spins. Yeah. All right, Ragama. All right. Cool. Let's go on and talk about what we have planned for today. Yeah. As I told you, अगर एक से ज़्यादा electron है, then things become interesting. Okay. So if you have, say, multiple different electrons, then there's something called this thing called penetration power, which is like sounds like what on earth is what is penetration power? It makes no sense. All right, think about it like this: like I've got the nucleus in the middle. I know orbitals don't look like this. I've got some sort of electrons running around in S shells. I can only have 2, right, in the first one. So let's say this is the 1s shell. Okay, 1s subshell. Now, isme I can have 2 electrons, and just after this I have 2s, then I have 3s, I have 2p, I have 3s, I have 3p, then I have 4s, Well, I technically have 3D, but filling order is 4s and then uske baad 3D, etc., etc., etc. So the way that these electrons shield the outer electrons is very different when you go above and above. Hydration energy, it's in bonding, Arnav. Arnav, bro, I can't do this anymore. Please ping me here if you want to talk about random things that are not related to this. Yeah. Uh, Teaching periodic table, we'll stick to that. Ping me here if you want to talk about anything else. Pranam, Shubhi, namaste. Steve, it's a theoretical idea. Anything can happen in theoretical physics. Did you read the question? That was the question. You have to figure out if you have three spins, then what happens. Yeah. So there is something called the shielding effect that happens, which is basically okay. Bahar ke electrons are shielded by the ones that are closer to the nucleus. It kind of makes sense, right? If you've got multiple electrons already there, right? Think about it like this. I've got one electron on the outside and I've got a couple of electrons on the inside. So the outermost one is shielded by the innermost one, just like you've got guards of a king or whatever. You've got multiple layers, like bowling pins. Only until you hit the first pin, then you get to the next, then you get to the next one. So electrons are basically shielded from inner electrons from being attracted by the nucleus. Does that make sense? Does that make sense? Yeah. So the ones that are closer to the nucleus get pulled in easily. The ones that are further away, they don't get pulled in that easily, theoretically. Okay, cool, cool, cool. But this shielding is not that good. You would think that shielding is good, but shielding is not that good. I'll tell you what I mean. Okay, this is the craziest part. This is the craziest part. Uh, the shielding power, S has the best power, and even that, if you want to look at some numbers like some 0.85 or some 0.65, some Slater's rule, kuch cheeze hain. S has the best shielding power. Even that's not so great. P is not that good. D is bad, and F is just like practically no shielding, right? F is practically no shielding whatsoever. I'll tell you, it has a really awesome implication, which I can show you right now. The ineffective shielding of F block, we can see that right now. Let's go back to this guy here. So see here, there is this element called hafnium. I'm going out of the syllabus, it doesn't matter. You'll read it later on. The element called hafnium right over here, right? You'll learn this in later sessions, but anyway, we'll do it here right now. What's the big deal? Hafnium, okay? You can see that it has this क्या बोलते हैं इसको radius? No, it's not radius. Let's select the radius property right over here. Where's radius? This is the beautiful thing about this, right? Wait, electronegativity, electron affinity, and I should radius calculated. All right, cool. I've selected radius. So you see the color of these things kind of change. The color tries to show that, okay, if there's a variation color, there's a different radius. Like, see, these are really small, so they are darker, and the light ones are larger radii. Okay, now look at this. We'll look at zirconium and hafnium. It's very interesting, right? Between zirconium and hafnium, there are how many electrons? There are literally like 32 electrons, okay? 10 of D or like 8 of D. Then there are some 6 of P block. Then uske baad some more here, some more here. So totally there are 32 electrons between zirconium and hafnium. You see the atomic number, zirconium is 40, hafnium is 72. But the atomic radius of zirconium hafnium is exactly the same, almost exactly the same. One is 206, one is 208. Why? Because the F block does not shield the electrons really well. There is this whole thing, 57 to 71, right? Lot of like 14 literal elements that are there between these two, but their shielding is bad. This is why the radius of hafnium and zirconium is the same, pretty much the same, right? This is to show you with data that F has really poor shielding of electrons. Shielding matlab uske baad aa raha hai. Anything that comes after F is going to be badly shielded, which means it will come in closer to the nucleus. So I'm again saying this. To understand what shielding effect means, I'm talking about जो outermost electron है, that being shielded by inner electrons. So if F block comes and there are some electrons after the F block, they are poorly shielded by the F block elements. Okay, cool. So this is why hafnium and zirconium have nearly the same radius. We just saw that with some data. What was it? 206 and 208 picometers is the unit. All right, cool. Okay, let me kick out some people who are disturbing other people. Hold on. Give me one moment, please. All right, cool. You're all awesome. You figured it out. shielded, beautiful, getting it. All right, great, good to know, कोई भी spam करता है मुझे तुरंत बता देगा, उसको भगा देंगे. I don't have time for any people doing time pass here. They have all the पूरा इंटरनेट उनके पास टाइम वेस्ट करने के लिए. यहाँ पे करेंगे, भगा दिए जाएंगे. जितने अकाउंट मैंने बना, आजा. I'm here. So what we're going to do now is we're going to quickly look at the meaning of the shielding effect. What is the actual real life implication of shielding effect? It is crazy. I will blow your mind. Is that crazy? I've seen this. No, not you, Steve. Not you. Not you at all. You did not do anything, Steve. You're awesome. You're brilliant. There was some other random guy saying some things that we not related to what we are doing. So, usko hata diya maine. That's all. Steve, you're good, bro. You're awesome. All right, you're answering questions. So you're my favorite student. So you're answering questions. Look at this. This one is going to blow your mind, right? You would expect the nuclear charge. Effective nuclear charge. What is this new thing now? There's some graph here. It's saying effective nuclear charge is being plotted against atomic number. Now, what is effective nuclear charge? Okay. So I expect that if I have one atom with hydrogen which has one proton, uska effective nuclear charge will be 1. If it has 2, it will be 2. If it is 3, it will be 3. Look at this. At 3, the effective nuclear charge is no longer 3. You see that? It has fallen lower than the atomic number. Atomic number is 3. Look at this. Last May. Right at the end. Right? Look at lithium. It's a little small. Let me zoom in a bit. Okay. Check it out. So lithium, look at that. The graph is almost half. Why? Because in lithium, you have got a 2s electron right over there. I'm going to go back to this and write it down so that it's clear what I'm doing here. Yeah, let's go back to this awesome thing. Although ये सब लिखा है, all this has no meaning. Okay, so something लिखा हुआ है, maybe weird. So hydrogen is 1s1, helium is 1s2, lithium is 1s2, 2s1. Seems harmless, but look at the graph. The graph that I showed you. This is z equal to 1. Z equal to 2 was okay, not that great, but theek hai, better. Z equal to 3, this is what it's supposed to be. This is what it's supposed to be, right? And it was somewhere here, almost half of it, just very slightly more, because that means that 2s has not that great shielding. And when you keep going, looking at that graph, right? If you keep going more and more to the right, it becomes crazy. Look at that. At neon, we are still kind of okay. And then after that, the sodium Z effective looks like it's that of beryllium. Okay. The effect of this is going to come onto atomic radii. That's why I'm talking about this into detail. Yes, Rajanya ne bilkul badhiya अंग्रेजी में ये बोला. Yeah. Yes. Due to penetration leading to shielding effects, thereby leading to contraction of lanthanide elements in similar atomic radii of zirconium and hafnium. So Rajanya was talking about the extreme effect of shielding. I've shown you a basic effect of shielding from elements 1 to 20. It's a wonderful resource. This is ChemLibreText. If you want to know what I'm sharing on my screen right now, I'm going to share this with you right here as well. Isn't that wonderful? Look at this. It is crazy. अच्छा ये तो पूरा दे ही नहीं रहा है. It's saying the text is too long. खैर ढूंढ लेना तुम लोग. Anybody who talks about anything other than what we are doing here is going to go in a timeout. I don't care what they talk about. ठीक है? Cool. So here, this is cool. Any doubts here? We are good, right? Look at this and appreciate this madness, right? That pink line is supposed to be the atomic number, the charge, the positive charge you'd expect, kq square by r square, right? That's the force you expect. Energy is kq square by r, but that's not what happens at all. This is absolutely mental, okay? And just going from here, this is what happened between here and here, by the way. यहाँ और यहाँ पे क्या हुआ? एक extra shell आ गया. One extra shell got added between neon and sodium. But look at this very, very carefully. Between sodium, if I were to compare, like I'm going to take a screenshot over here, okay? And we're just going to compare two things. It looks like there's a big change, but let's still compare something, okay? Hold on. This is slide number, multitasking is hard, but I'm going to try my best. 17, 18. Okay, this is slide number 18. So I'm going to put this right here. Okay, मैंने डाल दिया इसको. And we're basically going to compare what happens to group 1 and group 2 elements specifically as you go down the group. ठीक है? As you go down the group. Down the group मतलब ऊपर से नीचे, है ना? That's all I'm saying. All right, just give me a moment. Okay. All right, I think this is more or less to scale. Okay, yeah, I think I've got it right. I think we've got it right. Let's go back to our slides. Let's go back to slides. काफी हमने इसमें खिलवाड़ कर लिया. Yeah, check this out. Yeah, Shubhi, for sure. I'll repeat. See here. Yeah, look at this. Shubhi and Steve and everybody else who feel this weird is lagging. What's lagging? See here. Isko dekho. When I go down the group, yeah, what is lithium? Lithium का atomic number क्या है? Lithium is 3. This is 4. This is 3 plus 8, which means 11. And this is 4 plus 8, which is 12. So as I'm going down the group, the pink line increases a lot, but still, this is more than this. Okay, and this is more than this, which means that the atomic size will increase down the group. क्योंकि ठीक है, जितना भी जो भी प्रॉब्लम हो रही है, effective nuclear charge is increasing. It's not decreasing or anything, right? It'll increase. But something interesting happens when you go from left to right. Okay. See, I showed you an exaggerated picture which could confuse you, but this is the real life till. This is the real life thing. Okay. Okay. The charge of, say, magnesium is almost the same as that of carbon. If you draw a line, if you draw a straight line from magnesium onto this, not carbon, but nitrogen, right? Which is madness. Like, that makes no sense, but that's what the reality is. And I found this out after I started teaching. I did not know this during school. If I knew during school, I'd be like, oh, this is really cool. So I thought I'll share this with you. Okay, we'll look at these trends now. Okay. What is atomic radius? Oh, distance between the outermost electron and the center. Yeah, take it. ठीक है, size atom बहुत छोटा है. It's very difficult to find atomic radius. That's why you have to do crazy thing like find out Z effective that we can calculate using some awesome approximation on that, right? And you don't have any sharp boundaries when you talk about atomic size, but you measure it using the distance between two atoms. How do I get two atoms? Well, see, if I get a thing like nitrogen, or I get something like oxygen, or I get something like hydrogen, then I know that a distance between this, there's three bonds, there's two bonds, there's one bond. We'll study all this in bonding. Okay, how do I know there's two bonds, there's three bonds, there's one bond? How do I know? We'll study bonding. But for now, we know कि ये ऐसे exist करता है. So it is for me possible theoretically to isolate these guys and make them move really slow and sort of somehow measure them. Okay, that's the goal. It's possible. And मतलब measure मैं tape से थोड़ी ना करूँगा. I'll do it with something called X-ray diffraction. Remember, light behaves like a particle and a wave. And small particles, really small particles, behave as they have wave and particle nature. Yeah, that is what we use. So you use light at a very small wavelength, almost close to that of this, the size of these particles. Right? These particles are around some picometers. You'll use light at that wavelength. So there's something called X-ray diffraction that'll help you sort of see, quote unquote, let you see the size of those these elements and atoms and all of that. There are three kinds of radii we can look at. Okay, one is covalent radii, which is, as I told you, in oxygen, in hydrogen, in nitrogen, these kind of things, or metallic radii. So I have sodium, which is in a sea of electrons. You have mugged this, haven't you? You have mugged this in school, in 10th grade, in 9th grade. These sodium metals float in a sea of electrons. So they have some sort of bonding between them. Yeah, and the reason behind this bonding आपको पढ़ाया गया होगा कि बहुत ढेर सारे इलेक्ट्रॉन वो जो सेंट्रल जो न्यूक्लियस होता है उससे अट्रैक्ट होते हैं, एंड ऑल ऑफ देम आर अट्रैक्टेड बाय ऑल डिफरेंट न्यूक्लियाई, एंड दैट इज व्हाट लीड्स टू मेटालिक बॉन्डिंग. ठीक है, we'll say that that's metallic radii. Okay, van der Waals radii, this is a little bit complicated. We won't talk about this in so much detail right now, but these are the different kind of things, right? So covalent radii is normally used for non-metals and picometers and angstrom, right? And the whole deal is metallic radii दो को लो, उसका आधा distance is this, half the internuclear distance is this. NB minus Na by 2 is the formula for bond order. अरे वाह मेरे जियो मेरे लाल. Edu Express says NB minus. Yeah, sure, you're right. It is nothing to do with atomic radius. What you're talking about is number of bonding minus anti-bonding molecular. But ठीक है, Edu Express. We will talk about that in chemical bonding. If you are eager to check it out right now, let me show you where you can go to do that right away. Yeah, for Edu Express, anybody else who like मुझे तुरंत अभी right now bonding पढ़नी है. The good thing is that although in this year bonding is left to do, you can go look at last year's videos. You want to see where they're at? You can go to the description or you can go to the pinned comment over here. Go to these bento links and you can check out my video. Just go Control F and go to chemical bonding. कहाँ गया? आजा भाई. There you go. And you click on chemical bonding, you see all my sessions, you can check them out. All right, let's get back to what we're talking about. All right, cool, you're good. If you want to watch those videos, you can. Feel free to do that. And awesome, they're good fun. Really. I've made all of those videos using JDL, so you'll have fun doing them as well. Most welcome, Shubhi. I hope this made sense to you. Naga Reddy, Rise and Shine, everybody. Is this good? Is this good? You guys are understanding stuff? All right. So here's a, like a pictorial representation of all of these things. Ooh, look at that. Ionic bond. Ionic radii bhi बात कर सकते हैं. ठीक है. Van der Waals radius, it's a little complicated, but let's just call it covalent radius for now. It's the same as Van der Waals radius. Let's just say that for now. ठीक है. Yeah, we'll look at all of these things in detail in later sessions. Yeah. For now, we will focus on, let's just say कि you've used different ways to calculate the radius, and somehow you have got the radius of all of these things. Now, sometimes we'll talk about the covalent radius, sometimes we'll talk about the metallic radius, because obviously carbon का covalent radius होगा, sodium का metallic radius होगा, right? But at our level, we'll say कि it is just radius of the atom. Okay, cool, we good? We'll just call it radius of the atom for now. What is the order of, here you go, my friend. What is the order? It's around picometers. As I told you, it's all in a few picometers, right? If you want to look at the actual numbers, Naga Reddy ji, you got to go back to this periodic table. Yeah, I like tech, Rise and Shine. Love it. Absolutely fine. I've grown up with it. So you get used to it. You go to here. Then yahan pe jaiye. You see this? Naga Reddy ji? That's why I told you get ptable.com. Yeah? You see this. I have selected from this right here, radius calculated. Okay. I've just selected this. See, there are many empirical, covalent, van der Waals. Sab cheez yahan pe bhi di. See, everything I told you, I don't think it's showing up for you. It's not showing up. Yeah, when I click on that drop down, it does not show you this. Okay, but anyway, yeah, covalent is here, calculated is here. You can see all those things. So I will just go to calculated, and all of these values are given over here. And what is this in? It is in picometers. It says that right over here. Chota sa likha hai. Yeah, the unit is very small. It's grayed out. I don't know if you can see it. So it's a couple of 100 picometers. That's what it looks like. All right. We're going to go back to the session right now. That's the order. That's the order. It shows you. Okay, great. Good to know. And generally, if there's more overlapping, radius is lower, right? So covalent radius is going to be the largest. Then van der Waals radius is going to be the largest, metallic then, and then covalent the smallest. Covalent bonds are pretty strong as compared to these two. The strongest are obviously ionic bonds, but we're not going to talk about them right now. Most of our conversations today is going to be on covalent bonds. Ionic bonds are spoken of in solid state, which very nicely has been removed for you. So yay! Okay, now the easiest one, as I told you, and I showed you with examples of sodium and lithium. In दोनों का example आपको दिखा चुका हूँ, right? The easiest one is as you go down the group, then radius increases. Give me a thumbs up if this makes sense to you. It's a really easy idea, not complicated at all, right? You can look at this. You can look at this. Yeah, we're going to keep alt tabbing. Look at this. Look at the last line over there. Last, lithium, sodium. See, hydrogen is 53, lithium is 167, sodium is 190, potassium is 243, rubidium is 265, cesium is 298, right? As you're going down, these numbers are increasing as expected. Yeah, this chill. Nothing that stands out. No exceptions in chemistry, right? Oh, and things become interesting. Things become interesting when you go across a period. All right, we're going to spend a little bit of time on this one. This is where things become interesting. All right, great. Hey, Hare Krishna, Rishabh, how are you doing, hero? कैसे हो? कल नेक्स्ट का एग्जाम लिख रहे हो क्या आप? Rishabh is an awesome student who's been following our sessions for some time now. Yeah. All right, cool. So across a period, something weird happens, right? And this is what is going to blow your mind away. Across a period, the largest atom is the first one. I'm going to say one more time. Across a period, when I go from left to right, so I'm going basically from lithium to beryllium, then boron, then carbon, then nitrogen, then oxygen, then fluorine. So I'm going from atomic number 3, 4, 5, 6, 7, 8, and 9. Atomic number 3 has the largest radius, which is crazy. Hey, Hare Krishna Jatsa, how are you doing? Good to see you. You're from Vrindavan, aren't you? I remember you. That's great. Where is neon? Nagaji, neon chahiye aapko? Here you go. Here is neon. Where is neon? I like this guy. Here is neon. Dekho? Right on top of my head. Neon, 38. If you don't believe those graphs, see this. These are actual data. Lithium is 167, beryllium is, you don't have to remember. Please don't remember all this. You have the periodic table, open it, look at it. 167, 112, 87, 67, 56, 50, 48. What? How is it? Why is it that when you go from left to right, in a period, the atomic radius decreases? Let's go back to that picture, that beautiful picture that you had over here, this picture. What does this picture tell you? A picture was 1,000 words. Maybe we'll take 50 words from this one. जय हिंद नितिन, I get you. नहीं दे रहा. अच्छा, CUT का result. All the best. सब बताना how things turn out. Group 18 में atomic number 10 is located. Yes, Edu Express. You're absolutely right. Atomic number 10 कहाँ पे? Neon. I should be able to write on this. Actually, I can't write on this. This is a web page. Can we do something to make us write on it? I think we can write to this. Let's be shameless. इसको हम लोग let's make it into a let's make it a PDF and just write on it. Because I really want to write on this. Give me a second. Give me 30 seconds and we'll do this. Desktop. Save on desktop. Yeah, we will do this. We'll do this. Yeah, all the time in the world. Awesome Saturday. We'll figure this out very quickly. F5. Save कर ले मेरे भाई. Desktop में ठीक है कर ले. Let's just call it one.pdf and save it. And then we'll quickly open it up. Date modified, date modified, date modified. Where do you go? Oh, it's not here. It's on desktop. All right. Perfect. अरे भाई इधर आओ. Come here. Awesome. Yes. Now we can scribble on this. Yeah. Okay. Yay. We're going to have fun with this. We're going to have fun with this. Okay. Little low resolution, but it's all right. Bhavana ko samjho. See here. What happens here? What is the big deal here between this and this? This is atomic number 10. This is number 11. So you have 3, 4. Isko chodo. This is 1 and 2. Then you have 3, 4, 5, 6, 7, 8, and 9. And we're going to focus on this line. Like this pink line is ideal and we don't care about that. This is ideal and we don't care about ideal stuff. Okay, we care about this. We care about the gray line. Okay, how do you spell gray? Gray? Anyway, we care about the gray line. So you see that it is very clear that the effective nuclear charge is increasing. As you go from left to right, the effective nuclear charge is increasing. Which means the number of protons increasing, obviously. So what? Well, look, it's the same shell. The difference between these two is the number of shells is changing. What shells? K shell, L shell, M shell. So shell number 1, shell number 2, shell number 3. These are shells. So in the same shell, in the same second shell, you are increasing protons, you're increasing the nuclear charge, but electron to utne hi shell hai na. The space, physical space is the same. Do you remember that nucleus kitna chota hota hai? Nucleus is 10 power minus 15 meters and the atom is 10 power minus 10 meters. So there's an order of magnitude difference, which is why I'm saying if you go from left to right, the number of shells is the same, but protons increases, so it contracts. Yeah, that's it. That's it. You got it? Yeah, it's all right. Chrome extension. All right, check it out. I'm using Edge though. I'm not using a Chrome extension. Tell me more about that, Ryzen Shine. You can ping me on iTeachChem. Does this make sense? Is everybody okay on this? This is a superly important idea. Yeah, please don't mug this. If you understand it now, you'll never forget it in your life. So think about this and tell me if you guys have any questions. Give me a thumbs up if this makes sense. When you go from left to right, the atomic radius decreases because the effective nuclear charge increases because you're in the same shell. The moment the shell increases, you've got one more shell, then it gets larger, as expected. Okay, cool. I have a couple of people saying that the audio is large, audio is low. Does somebody else also feel this? It's at the max, but okay, I'm gonna, because you're the second person saying this, let me check out my microphone setup right now. How do I do that? Sound. Give me a second. We'll take a 30-second detour to address this sound wala scene because the second person saying it, unless it's the same guy who's made another account and who's come and said this, that would be, yeah, how do you do that? I don't think people do that. HDMI? No. What? The audio needs to come from here. Stereo mix. No, not here. What are you talking about? Stereo mix, AMD. Oh God, this is confusing. Allow. Hey, this is working fine. Okay. How about this now? Is it too loud? Is it better? Is it louder? I've increased the microphone gain. Did that help? It was at 40, I made 65. I have to go all the way to 100. Oh shoot, that's really loud. I'm going to reduce that to 75. Okay, is this better? Are you all right now? Is the audio better now? It's going to the reds, which is not good. Hello. Mic testing 1, 2. Yeah, we good? Shall we continue the session? Clear, louder. Yeah. Divya, you're awesome. And sorry, जो भी पहले मुझे बोल रहा था, it was not loud, very loud. All right, now. Yeah, okay, cool. All right, Divya. Anybody else who feels this loud, थोड़ा volume कम कर लो. Abhi I'm going to stop doing this audio video testing and we're going to go back to a session. Rahul, pranam. Yes, आपके लिए ये Rahul. This 26 के लिए ये. I'm doing 11th grade का sessions. Okay, cool. So that was effective atomic Z effect, which is effective nuclear charge. Screening effect. अगर screening effect ज्यादा हुआ तो atomic radius कम होगा. अगर screening कम हुई तो atomic radius बढ़ जाएगा. Okay. So the screening effect is going to be much more for cesium as compared to rubidium as compared to this. Hence, their size is going to be larger. Yeah. So, all right, Divya, no, you're okay. You're great. Divya, thanks for telling me. I would not have foreknown. There was another person saying it, but he was the only guy. But since you're a second person saying it, now I know for sure there was an issue. So, thank you for helping me out. In fact, I don't know what happened there, but we fixed it now. So, thanks. Okay. So, in a group, what is a group? Group क्या होता है? मैं भूल जाता था, आपको बताना जरूरी है. Group is what? Vertical. एक ग्रुप क्या होता है? वर्टिकल. पीरियड क्या होता है? हॉरिजॉन्टल. हाउ डू आई रिमेंबर कि ग्रुप इज वर्टिकल? क्योंकि एक ग्रुप की प्रॉपर्टी सेम होती है. ग्रुप की प्रॉपर्टीज क्यों सेम होंगी? इफ दे आर रिपीटेड एलिमेंट्स. रिपीटेड एलिमेंट्स कब होंगे? वर्टिकली. 8, 18, 32, whatever, hence you remember group logic. Okay, cool. This is why this is the graph from NCERT that's relevant to us right now. Okay, Rise and Shine. I'll do that later. Thank you. Okay. So, there's something wonderful that happens over here. Right? Till here, there's sort of a regular increase, and then the increase is not that regular. And there's a sudden bump. You see that here? काफी बड़ा फिर कम बढ़ गया. What is the difference? What's happening here? This is atomic number 3. This is number 11. This is 19. And then there's a big difference here. 19 plus 18 कितना होता है? 33. You see, because there's a big difference between 19 and 33, the shielding is also not that good because you have S, you have P, and you have D electrons. Those D electrons are not good at shielding. इसीलिए the jump between this and this is not as much as between this and this. I'm talking about this jump, yeah? This jump is lower than this. You see that, right? It's very clear. There's no doubt about this whatsoever. Because D electrons are बीच में and D is not accurate shielding. Same idea here. Yeah, fluorine and chlorine के बीच में versus chlorine versus bromine के बीच में jump. It's not that great. All right, cool. Across a period, I told you this is the graph also from NCERT. We'll look at the parallel graphs in NCERT also. Just give me a second. We'll do that right away. NCERT. बताया था, I told you I'll do these two graphs and you've done those graphs. Khatam. This is more or less done. Yeah. It looks like we took a lot of time to just do a couple of things, but I feel it was worth it. You see, these are two graphs we've just done. This is down group. This is across period. Why? Because Z effective increases. Okay, cool. Exponentially decreases. And this is almost linear increase. Okay. तो ये शब्द जरूरी है. Exponential decrease and linear, ये सब शब्द जरूरी हैं because assertion reason में आते हैं. Here and there keep coming. So we are doing these things. All right. Cool. It's very easy stuff. It's not complicated at all. But once you do it, you're sorted. And weirdly, inert gas should have a really large radius. That's weird. Because there we talk about van der Waals radius. We don't talk about covalent radius anymore. Okay. What is this van der Waals radius now? Since we haven't spoken of van der Waals forces, it doesn't make sense to talk about van der Waals radius. But van der Waals forces are weak interactive forces. And weak attractive forces. Weak attractive forces. Okay. If you have heard of hydrogen bonding, yeah, pani, water, why is it so exceptional? Right? Water has a very, very high boiling point. It boils at 100 degrees Celsius. Other things are, look at anything around you, right? Pretty much nothing that has oxygen in it has that higher temperature. Nothing that has oxygen in it has that higher temperature. It's special because of hydrogen bonding, which is the van der Waals force. Van der Waals force is a weak force, but its effect can be pretty strong. Sounds weird, I know. We'll talk more about this in bonding, but since it's here, जबरदस्ती तो इसलिए बात करनी पड़ रही है. We'll look at इसका NCERT का analog. Okay, you see that here. कहाँ गया? अरे इसमें तो है ही नहीं, should be here. One second. Okay, here till here you have halogens, right? Halogen का दिया है और यहाँ पे metals का दिया है. This is down the group. I'm just looking for ionic radius. सब चीजें ठीक है. Oh, here you go. Look at this. Look at this radius. Look at this one right here. Right? You see helium, neon, argon, krypton, xenon. Their values are significantly higher than everything else because this is not radius, so this is delta H value. Sorry. Yeah. Van der Waals force is weak force. Divya, what is metallic radius? Metal sea of electrons. I'll tell you about it. Okay, Divya, I'll get back to you. This is not the radius thing. I'll talk about the radius thing in terms of this side. It is better here. Yeah. Let's go to this side and let's go and change this radius from calculated to Van der Waals. Now you see 154, very big numbers, 188. Yeah. Can you see those numbers? 188 is here, 202 is here. So they're pretty high numbers. So I told you this is going to be a little strange. For some elements, you report, the covalent radius, obviously, right? For sodium, talking about covalent radius makes no sense, right? So if I go to covalent radius of sodium, it gives you some value, but doesn't make sense. You need to talk about ionic radius there, because sodium doesn't really exist as a covalent compound. So NCERT doesn't talk about all this. NCERT just gives you a table saying, ye lo, ye hai radius. So some of these radii that are reported are covalent, some of them are empirical, some of them are metallic. Somebody asked, what is metallic radius? Okay, we'll talk about that. So usually, let's take the example of some random element. Let's say copper. One copper atom is theoretically, I may be off about this, you can check. Theoretically, it is surrounded by 6 other copper elements. Hypothetically, let's just call it metal X, not copper. Let's say X, some metal, okay? Because I'm not sure about whether copper is surrounded by 6 or 8, so we'll just call it X, okay? Metal X is surrounded by this. Surrounded means solid state, in the solid state. So the metallic radius will be the distance, half the distance between two of these. That's all. That is the metallic radius. Okay? It is called a lattice. You can read up on this later. Okay? In a metallic lattice, half the distance between 2 points is known as this. It's there. We've taught this in solid state. Again, solid state is something I've done. It's on the bento links. You can check it out if you want in detail. But yeah, that's all we'll talk about it. Yeah, exactly, Naga Reddy. All right, cool. What is the correct order of shielding effect of sp d and f orbitals? ठीक है, आपने कहानी बहुत सुन ली, बहुत अच्छा किया. थोड़ा सवाल कर लेते हैं ताकि we make sure that you understand what's going on. Yeah, what's happening here? Please tell me. What do you think is the answer to this one? Correct order of shielding effect. Now let's do some questions very quickly. All right, Shujat, बिल्कुल सही. 1 says Shujat. Lovely. जैसे ही मुझे एक आंसर मिलेगा, we'll move on because you guys are quick, you guys are awesome, and that's all you need. This is not rocket science. बिल्कुल सही. A. Mission MBBS. Yes, Mehak. Yes, Surabhi. Yes, Surabhi just saying yes. All right. Yeah. Next question. Increase in atomic size down the group is due to what? Yes, Naga Reddy. Absolutely. Increase in atomic size due to down the group. Why? Why? This looks like it's a bit too easy, isn't it? Yes, Divya, Shubhi. Absolutely right. ये वाला भी A क्या? Is this also A? This one also is A. Increase number of shells. Easy, very easy questions. Next one. All of you are right. Shraddha, everyone's right. Among the elements, calcium, magnesium, phosphorus, and chlorine, what is the order of increasing atomic radii? Calcium, magnesium, phosphorus, where do these guys sit? Everybody getting that? Okay. Pehle do everybody got right. What about this question? Can you try this question? Yes, Shubhi, absolutely right. Last one was A. What about this? Is this one also A? We have to think about this one carefully. Let's draw a mini periodic table just for us. Okay, calcium, okay, magnesium, okay, phosphorus, okay, chlorine. Why am I drawing it like this? Because this is sodium, this is potassium, and there's some other stuff here. Aluminium. What's after aluminium? Aluminium ke baad silicon, then phosphorus. What's after phosphorus? Sodium, then chlorine, 16, 17, and then neon, argon. Look at that. Okay, but we don't need all these guys. We don't care about that. We want to look at phosphorus, chlorine, magnesium, and calcium. The 4 highlighted elements. What is the order of their increasing atomic radii? Shujat and Arya and Divya have got it right. Excellent work. Yes, bilkul sahi. How did you get right? The moment I drew this and highlighted it, so this is what you have to do in your head, huh? You have to draw this in your head very quickly. Okay, or at least figure it out. जैसा तुमको ठीक लगे. Calcium is obviously the highest. Why? Because it is down the group. It has to go down the group, बढ़ जाता है. Okay. Then chlorine will be the smallest because it is in one period pehle, or it's in the end of that period. It's completely at the end of that period right over here. That's going to be the smallest. Okay. So chlorine at the end, calcium at the highest. Okay. So B is the answer. That's just with this you got the answer. Excellent work. Yes, Shubhi and Nagar Reddy, absolutely. The correct order of increasing atomic radii for the following elements. Hi, selenium kya hai? What is Se? Se selenium, I told you right now. Oh, this is slightly more difficult, huh? Okay, let's put carbon, silicon, germanium, not helpful. Carbon, oxygen, sulfur, selenium. This is a little hard, huh? How do you do this? Is this correct? Let's look at the periodic table. Kisko yaad hai? Who remembers all this, man? Let's go back to the periodic table. Where is carbon? Carbon is here. Oxygen is here. Carbon, silicon, germanium. Oh, I was right. Oxygen, sulfur, selenium. Okay, that वो भी सही था. ठीक है. This was right. I know. There is a nitrogen in between, and we didn't care about it. ठीक है, nitrogen है. Don't worry about it. Now what do we do? B. इसमें भी B. Arya and Divya are saying B on this one as well. Let's see. B, huh? मतलब selenium must be the largest. Okay, because it is third group. No, not even third. This is, sorry, fourth period. बहुत नीचे. Fourth period. Did I say right? Did I say that right? Fourth period is it? Let's look it up. Fourth period. हाँ, selenium is fourth period. Look at the period table. You don't have to mug it. Selenium is fourth period. Okay. It is the largest. So only options are this and this. You cancel these two out. Okay. Next, silicon. Silicon. Then sulfur. Okay. Cool. Okay. Between oxygen and carbon, carbon is larger because this is to the right and hence smaller than carbon. Okay. Hey, एक मिनट. तो D नहीं होगा. Naga saying D, शुजात भी D बोल रहा है. D नहीं होगा क्या? D होना चाहिए ना? है ना? Not B. Should be D, right? Let's see. Let's check with data also, just to be sure. कभी-कभी exception आता है ना chemistry में. Let's check. Carbon is larger. See here. You can see the numbers. ज़्यादा zoom हो गया. दिख रहा है ना? You can see. See, carbon is 77. अच्छा ठीक है, इसको छोड़ो. You don't want to see this? Let's look at NCERT. Let's look at NCERT. That is better, no? कहाँ गया? NCERT में वही दिया है दोस्त. NCERT says carbon is 77, oxygen is 66, selenium and all तो नहीं दिया है. Sulfur 104 दिया है. Oxygen should be the smallest, guys. Oxygen होगा सबसे छोटा. What do you think? Are you all convinced that oxygen is the smallest? We good? Shall we move on? Yes. A resounding yes, please. Yeah. It's going to be D. D for Delhi. I was going to say donkey, but that does not sound nice. Anyway, take it, whatever. Cool. Let's go back to this. D is the answer. All right, great. एक मिनट. Carbon is the largest. ये क्या बोला हमने? Order of increasing ना? एक मिनट. No. Hold on. Oxygen is the smallest. So B is the answer, no? Bro, क्या confuse यार रहे हो आप लोग? Oh, oxygen is the smallest. So सही तो बोला तुम लोगों ने. B बोल रहे थे. Why do you guys change your answer? Guys. It's B. It's not D. Why were you guys? It's B, right? We did the whole song and dance to tell you to the right, smaller, so oxygen is smallest, then carbon. Yes, Arya, you were right. B was correct. It's okay. कोई नहीं. हार कर जीतने वाले को बाजीगर बोलते हैं. So I guess we did that. So I'll tell you what. In the interest of time, let's quickly cover ionic radius also. ठीक है? Let's do ionic radius. Okay? Good job. Everybody got right. In the interest of time, we will move on to ionic radius. What is ionic radius? I already gave you an example, right? So say if I have, say, sodium atoms, which are these small ones are going to be small radius, sodium. This is chlorine. Right? Why is sodium small? Why is chlorine big? We'll see. Cation may, like say, what happens to sodium? Sodium loses one electron, loses an entire shell. Sodium, if calcium loses two electrons, loses an entire shell. बहुत छोटा हो जाता है. Cation gets smaller than its parent atom. Less electrons, and the electron to proton ratio is less than 1, which means you have more protons than electrons, so size shrinks. Also, you lose an entire shell, so size shrinks a lot. Okay, Z effective is really high. Anion is exactly the opposite. Anion, it tries to go to the next noble gas configuration, so it accepts electrons. Okay, there you have more electrons and protons. It's a noble gas configuration. बड़ा हो जाता है. It's huge. It gets really, really big. Okay. Here are the actual size of the cations and anions. You can see that chlorine atom is 99 and chloride is 184 picometers. Look at the numbers difference. Look at sodium. Sodium ion atom is 186 and the ion is 95. That's crazy. Unknown. I can't do it. Yeah, if you're serious, ping me on IT scam. If you're trolling, then not in the mood. Yeah, if you're serious, you can, I guess, read a book. Yeah, yeah, or ping me here, I suppose. I'm not here. If you're going to troll me, zero tolerance, not today. All right, cool. So we good. Ionic radii, when you got a positive ionic radii, becomes smaller. Negative ionic radii becomes larger. All right. With this, we come to this awesome thing called isoelectronic species. So now it is possible, for because you have ions, for many different species to have the same number of electrons, the same noble gas configuration. Okay, that is called an isoelectronic species. So if I look at these, okay, I've got multiple of them. All of them have the same number of electrons. This is 11 minus 1, this is 12 minus 2, this is 13 minus 3, this is 9 plus 1, this is 8 plus 2, this is 7 plus 3. What is a small color to highlight these numbers? This green is Z, or number of protons. So you can see that this is going to be huge. This is going to be tiny. And that's the order of ionic radii. Okay, for isoelectronic species, the smallest one is going to be the one that has the most protons and least electrons. And the substance that has the most electrons and least protons will be the largest, right? Okay. If you want to look this up on a periodic table, what will this look like? So let's go to the periodic table to check this out. So if I look at, say, let's look at this. Okay, I'm talking about nitrogen, oxygen, fluorine, all of them becoming nitride, N3 minus, O2 minus, F minus. So they get the noble gas configuration of any neon. That and Na and magnesium and aluminium, all of them also get that same noble gas configuration by losing electrons. So these will all form isoelectronic species. All right. Sweet, 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 sweet. Hold on. एक random लोग को थोड़ा टाइम पास जो कर रहा है भगा दिया जाए. ठीक है. All right. Sweet. Let's get back to this. All right. So that was what isoelectronic species is all about. Couple of small things to get out of the way, and we're done with today's session. Yeah. So for the same element now, yes, some elements are weird. They do everything. Yeah. What are you going to do? Size of the atom, uncharged. Anion is going to be larger. Cation is going to be smaller. Do you know of any element that does this? Any element that has both positive and negative? Socho. Well, you have hydrogen, you have H plus, you have hydride, H minus. Yeah. You have carbon. Carbon is a little weird. Carbon is weird, isn't it? Carbon is weird. What other thing comes to mind? Carbon level kuch aata hai dimag mein. Carbon is weird. But carbon can have something called carbide, which is a really weird way of doing things, right? it cannot have a 4 minus charge, right? And that's why you do start with organic chemistry. You can't have 4 plus 4 minus, so you do whatever. But yeah. Arya, exceptions. I told you some theory. If you want to read more theory, you can check out NCERT, right? I've told you a little bit more than what is in NCERT already. But when you say exception, it's a very broad term. So we'll look at specific examples as we do P block, and we'll see the exceptions. Okay, specifically, Arya. There are exceptions. I'm not saying there aren't, right? कुछ जगह exceptions हैं. किस type के exceptions हैं वो we'll explore when we study P block में specific groups. We'll look at it there. Okay. At this point, talk about exception will just confuse you. All right. Thank you, Shubhi, for the feedback. Okay. So इनमें से कौन सा सही statement है? 3 statements हैं. Ionic radius of metal, 4 statement is same as that of atomic radius. Ionic radius. No, this is not right. Ionic radius of metal is greater than atomic radius. We'll see. Atomic radius of metal is more than ionic radius. What? Ionic radius of metal is less than atomic. Which one do you think is correct? I've got 4 statements. We're comparing ionic and atomic radius. Okay. Oh, we can do this. Metal. Metal was 186. Na plus was 95. Obviously, it's this one, right? Ionic radius of the metal is greater because you're forming a plus ion. Wait, ionic radius of a metal is smaller than the actual radius. We just saw that with numbers. We saw numbers. Yeah. Naga Reddy, xenon forms compounds. Otherwise, they don't. Yeah, most of them don't, but xenon forms compounds. Out of these, सबसे largest size कौन सा है? What's up, Yusuf? Out of these, which is the largest size? Can you figure this out? That's it. Everything we've done today will definitely help you in competitive exam. Whether it's JEE, NEET, school, kahan pe bhi hai, any MCQs, they love the periodic table. Questions come from this all the time. The largest. Hey, Sujat, dhyan se look at this. Okay, let's go one step back. 7, 8, 9. This is the number of protons. What is the number of electrons? 7 plus 3 plus 2 plus 1. 10, 10, 10. So, you have same number of electrons, lower number of protons will have a larger size. Hai na? Sujat? Yeah, you figured it out. Yes, Naga, Yusuf. Absolutely. No, why? Everyone's saying C. What are you guys doing, guys? Some of C kyun bol rahe ho? They can't have the same size. All right, Arya. Good to hear. Good to hear that you cleared JEE Main. Congratulations on that. And all the best for your repeating journey. Arya, my suggestion to you, although you have not asked, is to solve all questions from NCERT, from NCERT exemplar, and also to read lab manuals inside out. If you do this, you will easily get close to 80 to 90 marks in JEE Main from out of 100. This is a possibility if you do all of this. And obviously, test taking is a thing. Learning testing अलग अलग होता है. दोस्तों, why are you guys saying all of them have the same size? Right? अभी मैंने जो पढ़ाया है आपको, लगता है maybe that went over your head, so I'm going to repeat that one more time. Shujat, Naga, everybody, please listen up. If I've got the same protons, मतलब same charge, right? What is a proton? It's a positive charge. What is electron? Negative charge. I have more negative charge than positive charge. It gets larger. So this will be the largest. Right? Same electron, fewer protons. So it must be A. Yes, no, maybe. Not C. Can't be C. Right? I've just shown you why. Look at this. This is proton, this is electrons. All of them have same electrons. जिसका सबसे कम प्रोटॉन होंगे उसका साइज सबसे छोटा होगा ना. नो शुजात इज नॉट कंफ्यूज. इट्स डैम इजी. शुजात क्या बोल रहे हो? बहुत सिंपल है, कुछ दिमाग लगाना ही नहीं है. इट्स वेरी डायरेक्ट. सी व्हाट एम आई डूइंग हियर? आई एम सेइंग दैट देयर आर 7 पॉजिटिव चार्जेस, 10 नेगेटिव चार्जेस. बड़ा हो जाएगा ना. इफ आई हैव say 9 positive charges, 10 negative charges, it will be smaller. That's all. 7 positive, they don't attract 10 negative enough. That's all we're saying. Not complicated. Where is this complicated? This is not complicated. If it's complicated, I'll tell you it's complicated, I'll teach you, right? I'm not one of those guys जो जबरदस्ती सब चीज को आसान बोलता है, सब चीज मुश्किल बोलता है. This is not hard. थोड़ा पढ़ना पड़ेगा बस, थोड़ा practice करना पड़ेगा. Okay, now one more question for practice. the ions, all of these are isoelectronic. Their ionic radii show what? What do their ionic radii show? Significant increase from O2 minus to Al3 plus. Significant decrease from blah blah blah. Increase and then decrease. क्या है? कर लोगे? How do you do this? You want to take 30 seconds to answer this question? Unknown भाई आंसर दो. Try. Unknown जी try करो. Try the question. How do we do this? They're saying it's isoelectronic. Do the same process. Write the number of protons, which is the same as atomic number. कितने हैं इसके? 8, 9, 10, 12, 13. Then write electrons. कितने हैं सबके? 8 plus 2, 10. 10, 10, 10 और फिर 10. इसके 10 नहीं होंगे, इसके 11 होंगे. That was, yeah. ठीक है? So, जाहिर है कि if there are higher protons, then size is going to be smaller. So, we are going from left to right and size decreases. This is what I feel. What do you think? मुझे ये लगता है. All the best, rise and shine. हम तो शुरू से पढ़ा रहे हैं अननोन, आप पढ़ नहीं रहे हो. एनसीईआरटी पढ़ो मेरे दोस्त. ठीक है. Significant increase from O2 minus to Al3 plus. How is there increase, bro? It's a decrease. Why are you saying A? Unknown. I have just explained to you. अंग्रेजी में लिखा भी है size decreases. फिर भी आप A बोल रहे हो which is size increases. Why? शुजात बिल्कुल सही. A significant decrease from O2 minus to Al3 plus. Why? Because you got the same number of electrons. The protons increase from left to right. Right? When you go from anions to cations, proton increase, which means the size becomes smaller. You got more positive charges, fewer negative charges. Significant decrease from is absolutely right. More practice. Another question. Identify the correct order of atomic radii. Unknown फिर से try कर. Don't worry about it. Sorry होने मत बोल. फिर से try कर. राजन शान भाई तुम लोग कर रहे हैं, practice ही तो कर रहे हैं. Yes, unknown, absolutely. Shubhi, you want to try this question out as well? What is the correct order of atomic radii? This is just more practice of what we've already done. Oh, Rise and Shine wants practice for first and second session. When is your test? Monday. यार परसों आए तो मैं आज क्या करूंगा तुम्हारे लिए? Go download the app. There is a link. आकाश बायजूस ऐप है. उस पे जाके प्रैक्टिस कर लो ना. Things you make me do. आयुष says C. बाकी लोग बताओ क्या है, तुरंत बताओ. I'll show you how to use the app very quickly. It's free, bro. Obviously, if you want to like watch videos, you're going to pay, but like most of the stuff on there, which people don't know, practice is completely free. So why not do it? Let me figure that out. Your phone link. Answer बताओ तब तक मैं इसको तब तक दिखाता हूँ how to use the app. Phone link इधर है. I showed it last time around as well. I don't know if you guys saw it. Link to Windows. Okay. Go to photos. Maybe later I want to show photos of wrong with you, bro. All right. Beautiful. What have I? Oh, this is the wrong phone. Give me 1 second, guys. Shoot. How do we do this? I have 2 devices connected. Let's connect the other device. NCRT is enough for JE. C. King Skylar's on fire. Divanshu's on B. तुम लोग मस्त हो भाई. Yeah. All right. Cool. So what's the order of atomic radii? You've got calcium 2 plus. Okay, C. I like C. But also I love C. C is the answer. Good job, everybody who said C. King Skylar on fire. Why is C correct? Let's do that same exercise again. What is the number of Z? मतलब protons कितने हैं? You've got, how many do you have here? 20? You've got 19, you've got 18, you've got 17, you've got 16. What about electrons? Electrons सब में 18 ही हैं. Right? So obviously this is the smallest. Good job, King Skylar. And Drishti Solanki, the only 2 people who gave us the right answer. Lovely. Rise and Shine, I will definitely do it. Rise and Shine, this is my plan for next week. But since you brought it up, I'm going to quickly share my screen with you. I'm still figuring out how to do that. I think I've got it. I've got it. Gosh, I do that for J. In moment. Give me 1 minute. Oh, you can see the tablet. Sorry about that. It's a little large. What do I? Oh, great. Oh, you can't see that, thankfully. That's my number being displayed randomly. Good job, everybody. Oh, congrats, Ahimai Singh. बढ़िया 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 ठीक है ये हम लोग अगली बार करेंगे आयोनाइजेशन एनर्जी अभी के लिए because somebody wants has a test somebody has a test on Monday right I'm going to focus on their test right now unknown भाई तू मुझे 5 बार बोलेगा 5 बार बोलने से मेरा आंसर बदल तो नहीं जाएगा ना हाँ भाई बता powerpoint.exe your phone थोड़ा बड़ा हो गया क्या what why is it so tiny dude oh because this tiny let there be light थोड़ा बड़ा हो गया okay ठीक है this is the app all right और बड़ा कर सकते हैं क्या I don't know क्या मैं ला जा I closed it dude this tech stuff bro sorry about that oh guys रुको this is the app all right okay let's go to chemistry कौन सा टेस्ट है तुम्हारा बताओ चैट में जल्दी से बताओ एटॉमिक स्ट्रक्चर का टेस्ट है ना और मोल कॉन्सेप्ट का these videos are crazy bro like if you want to check these out okay I'm not just saying this because I worked on them but they're actually pretty crazy so go right to the end click on exercise let me go to the other side I feel like I'm obscuring your view let's move this here and मैं चला जाता हूं दूसरी तरफ कहां जाए हम जाते हैं उधर yes we figured this out rocket science it feels right all right so this is the practice section just go to I've been doing this anyway in Rutherford scattering experiment this is not in your syllabus but we'll skip it photon ka wavelength kya hai figure it out guys I'm going to just put a 5 as the answer here I'm going to get wrong answers here to show you like even if you can completely mess up it's going to figure stuff out for you it's going to tell you okay I don't like this I'm going to bookmark this question I'm going to end practice quit and then I start again it goes at the exact same spot but it gives you different questions which you can answer and if you get it right which I fluked it gives you solutions sab cheezein hain there's a practice section I'll do it properly I'm going to plan this you have ruined my surprise I was going to do this with you guys in a day's time not in a day's time like next week मैं साथ करने वाला था ये but thanks for ruining my surprise you're awesome though कौन पूछ रहा था rise and shine chapter 1 and 2 right I've shown you how it works right if you want to show it to me one more time from the beginning यार ये बार-बार बंद क्यों जाता है रुको okay yeah here we go right I'm going to go right from the beginning just for the sake of my friend rise and shine you go to this chemistry I'll tell you the whole navigation process I'm at home literally and figuratively I'm on the home page and I go to chemistry okay then I go to whatever chapter I want I go to say mole concept go right to the end if you want to see some of my random videos they're here as well hey where did they go idhar kuch to kuch the no okay well there must be some practice here खैर इसमें है second chapter में है you see that there's a lot of practice going on there you go there go to explore go to practice that's it and this is free you don't have to pay for this I'm pretty sure you don't have to pay for this anything at all right it's the videos that are paid this part is not all right that was a quick yeah we went way over time today almost like a 1.5 घंटे का session I usually do 1 hour session that's all right I think we had fun so that's all I had planned for you today let's do ionization energy next time आप खुद ही थोड़ा पढ़ के आना ना I have finished atomic and ionic radius it took a little bit of time but I felt like students find it a little bit difficult so yeah I'm done let me look at the chat if I missed out on anything some people are repeating what they are saying from the starting मैं उनको already answer दे चुका हूँ but ठीक है cool no problem फिर से बोलो फिर से पूछ सकते हो anything on your mind any question you want to ask me you can reach out to me at iteachchem on Telegram and on Discord if you're wondering what is Telegram what is Discord come on guys which rock are we living under everybody is there no I'm just kidding you guys told me about this I don't know anything about any of these things it's you guys students who told me about what's happening on Telegram what's happening on Discord man I'm just a noob what did I do now okay still figuring out my tech all right we are back whoops okay cool so this is where you can find me those bento links I was talking about go there right to the end yeah and yeah on top first link Discord link second link feedback for my videos. Third link is my Telegram link. These two are my personal Telegram channels. If you want to check out our regular updates, we have a Telegram channel, the Akash Bayus one, where you can get updates for all our videos. All right. Thank you everybody for joining in. I'll see you around. Next class कब है? शुभी. Next class होगी मेरी आज क्या है? Saturday ना? Tuesday को मेरी next class होगी. You can come check it out. Unknown, yeah, bro. Of course it is enough. कितनी बार पूछेगा तू? All right. What else? What else? Did I miss out anybody else? Anybody else saying anything? You're most welcome, Rise and Shine. That's my job. Quick revision kar do. Unknown is funny, guys. Next class kab hai? All right, I'm done. Good night, everybody. Yeah, man. Rise, I have a timetable. I'll show you my timetable. मैं तुमको अभी तुरंत दिखा देता हूँ. ठीक है? That'll be. I'll tell you. I'm going to be live on 8:30 on Tuesday, Thursday, Saturday. ठीक है? And also on the JE channel. This is on the JE channel. On the NEET channel, and also on Mondays. So Monday, Tuesday, Thursday, Saturday, 8:30 p.m. and Tuesday, Thursday, Saturday on the NEET channel where I'm doing 12th grade stuff. So that's my schedule. An exact timetable, yeah. I gotta give that to you. I have mine sorted, just waiting for the other teachers to sort theirs out. So we'll share that with you. All right. Bye. Good night. See you all. Yeah. Rise and shine. Ping me on Discord and Telegram. I'll share stuff with you. Bye. All right. Tata. See you all. Good night. Have a good weekend. Yeah. And if you have any feedback for me, you know where to find me. You can give me comments on that or also leave comments here. मिलते रहेंगे. I hope you enjoyed the session. Please read the NCERT. That's the most important thing. Do exemplar questions right as soon as you're done with that. See you. Good night. Have a great weekend.